Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on RIP. Let's start our part 2.
So let's look into some of the configuration. Over here I have a simple lab to illustrate some of the basic concept that we went through just now. So I have R1, R2 and R3. Which R1 connect to R2 through the serial interface, having a network of 10.0.12 network, and R2 to R3 having a network of 10.0.23. So if I go to the display IP interface brief, you're able to see that I have a 10.0.12.1, and if I go to R2, I have both the interfaces. Okay, the interface that's facing to R3 is gigabit, and the interface that's facing to R1 is a serial interface. Let me do a test ping. Alright, so that will be an R1, 10.0.12.1, and let's do a ping to 23.3. Now each of these router have its own loopback interface. So if I go back to R1, you notice that the loopback interface is 1.1.1, router 2 is 2.2, and router 3 is 3.3. Okay, so let's just start the RIP, a very basic configuration of RIP. I'm going to start to use a version 2 because version 1 is pretty easy. I'm going to use a network 10. Alright, that's it. So we are going to do the same thing throughout the routers. Now what I'm going to demonstrate over here is some of the display commands. So it's very important for you to check if your RIP is running. So when I look into this command called display RIP1, you'll notice that the timer, we have the update timer of 30 seconds, H timer 180 seconds, and garbage collection timer of 120. And by default, you'll notice that we have some interfaces over here. Okay, so we are going to look into the interface. If we look into the display RIP1 interface, let's look into the interface S100. I'm going to look into the verbose. And you notice that the poison reverse is disabled, okay, as speed horizon is being enabled. That's the default. And if you still remember the concept about the speed horizon, if R1 sends this information to R2, R2 will not send this information back where the interface came from. Okay, whereas poison reverse mentioned that if you are going to send this information to me, I'm going to poison you with a unreachable metric of 16. So we are going to look into some of this configuration. So by now I should have the route of 2.2 and 3.3. Let's have a look. Display IP routing protocol RIP. Alright, so I have a 10.0.23. This is the network, but I have not receiving number 2 and number 3. The reason is because that I have not enabled the network 1, 2, and 3. So let me enable the network 1 here. I go to router 2, network 2. And number 3. Alright, so the update should have received. Okay, so let me do a display IP routing protocol RIP. So I have number 2 and number 3. Now one way for us to check on our route aging. So the command for you to do here is display RIP1 route. As you can see that 2.2.32, my next hop is 10.0.12.1, and you notice that R stands for RIP, A stands for its aging, and if you still remember, the aging will last for 180 seconds before it go into the garbage collect. So this timer indicates that it's just received about 1 second ago, and you notice that 24 seconds, 26 seconds, 28 seconds, 29, 31, and you notice that it will go back into number 1. By right, it should be going to 30-second maximum. So plus and minus some of the timers. So we have here the timer go back to number 1 again, as you can see from here. Okay, and if I go into number 2, it will be exactly the same. Display RIP 1 route. There you go. All right, so we have number 1 here, network number 1, and network number 3. And you notice that the update are slightly different because the update from R1 to R2 and R3 to R2 are at a different time. Now, for example, let's just configure our speed horizon. And before we actually do that, okay, let's check our Wireshark. So I start my Wireshark on the PPP here. And what you can see is my read version 2. Okay, so you can see that this is at 1 second. This is on the 10.0.12.2. So on the 31st second later on, I should see another update by 10.0.12.2. All right, so I'll just wait a little bit more. There you go. So you can see that this is 10.0.12.2. This has happened on the 28th second. All right, it's fast, a little bit faster than what I'm expecting. So this is 11. So at 11 second, and I plus another about 30. So it should be about 31. So you can see that this is slower than what I'm expecting. Right? Okay, so I'm going to do a split horizon. As you can see, the split horizon has been enabled. So if I go to the serial 000, interface serial 1000, I'm going to do a RIP split horizon. You will notice that the split horizon has been enabled. So I'm going to undo the RIP split horizon. Okay, so what will happen over here is when I do a display RIP 1 interface serial 1000 verbose, you'll notice that the split horizon has been disabled. Now if I do a Wireshark, okay, so you notice over here, what happened here is that when I do a information sending, 10.0.12.1, I'll send to 10.0.12.2, you'll notice over here that this information is being sent back to me. And if I go into the information here, you'll notice that I have a metric. All right, so you can see that this is what 2 sent to me. So when the router 2, 12.2 sent to me, it sent a 2.2.2 metric of 1, which is true. If you look into my network here, 2.2 is here. It sent to R1 as a hop of 1. Now, surprisingly, after I disable the split horizon, what you can see from here is you notice that number 1 send this update back to number 2. So the source here is 10.0.12.1. And if you look into the network here, you'll notice that the 2 network is being sent out with a metric of 2. Okay, so this is what happened when we disable the split horizon. So when 2 send this to R1, R1 is going to send back immediately to R2. So for us to prevent the loop, all right, this one's supposed to be enabled. Now what will happen if, let's say, the interface of R2, now we remove it. So if I go into the interface loopback 0, okay, let me show you here. This is 2.2. I'm going to undo interface loopback 0. So now this interface is gone. So if I go back and have a look, all right, now you notice over here that there's some sort of a loop actually has happened. Okay, so you notice that I have here 10.0.12. Okay, and you can see that I have a metric of 16. Okay, so this is our loop prevention. Now because that I'm actually sending out this information, you notice that this information is actually being updated by 10.0.12.1. Okay, 12.0.1. You notice that they actually send out a metric of 16. All right, for us to see clearer, let's just do a filtering. Okay, so I'm going to do a filter based on RIP. Now, when I shut down the interface on the loopback just now, you can see that this was by 12.2. This is before I shut down the interface or remove the interface. You can see that it actually sent out a metric of 1. And because the speed horizon has disabled, so R1 is sending back this information back to R2 saying that the metric is 2. Now, right when I shut down this interface, as you can see that this is still number 1 of a metric. And on this frame, you notice that this is where I actually shut it down. So at the 350-second, you can see that the network of number 2, okay, is actually a metric of 16. It's actually is a trigger update. You notice that? It's a trigger update. Immediately it's actually sent out saying that 2.2.2 is 16 hop. Now upon receive a information of the hop is 16, you notice that because the speed horizon has been disabled, router 1 is also sending out the metric as 16. Okay, this is prior that it received, and this once it's received is actually sent out as 16. So this is a trigger update and is being poisoned by R2 saying that the route is unreachable. So a hop in reality never appear. Okay. Next, I'm going to show you the poison reverse. So we go back to R1. As you can see that the speed horizon still has been disabled. So assuming that I will just let it disable and I go back into the serial 100, I'm going to do a RIP poison reverse. Okay, so with the poison reverse has been enabled, whatever the R2 advertised to R1, R1 is going to poison back to R2 with a metric hop of 16. So if we are going back into our Wireshark, okay, and we are going to monitor it. All right, so what you can see from here is our Wireshark. Okay, so if let's say we go in and have a look on R1, you notice that the R1 with the poison reverse enable, you notice that actually send back a metric of 16. All right, the tree network is a metric of 16. So this is where the poison reverse has been enabled. Okay, so if let's say I have enabled speed horizon and the reverse poison reverse will be having a higher priority, will take precedence. So if I do a display RIP1 interface S100 with a verbose, you notice that the poison reverse has enabled. All right, so let's look into the trigger update now. So if I in the R1 I do a display RIP1, as you can see that we have our update time of 30, aging time of 180, and garbage collection of 120. So for me to demonstrate the trigger update, I'll go to R3 and I'm going to do a removal of the interface of 3.3. As you can see that the interface of loopback is still available, and in R1 if I do a display IP routing protocol RIP, you notice that I have 3.3, and when I look into the timer on the aging, you can see that it was 13 seconds ago being advertised by router 2. Now trigger update work when the interface go down, it will send this information straight to the next router, and this is what happens. So if I do removal of the interface, undo interface loopback 0, press enter, and I go to R2, display RIP1 route. Okay, so you can see that it straight away go into the garbage collection, and the aging on the garbage collection start to count down. On R1, you notice that it's also going to the garbage collection, and this is the aging. And once you go up to 120 seconds, this route will be deleted. Okay, so we will wait for the 120 seconds, and definitely I'm going to pause this, and I will continue before it reach up to 120 seconds. All right, so closer to 120 seconds, so you can see that now it's 120, and immediately this route is being deleted from my routing database on R1. Okay, so what you can see here is that the garbage collection as well as the trigger update. So I'm going to reinstate back the route. Okay, so once I reinstate back the route, and I'm going to have a look on the entry. Right, there you go. All right, so the entry has been propagated and it has been reinstated back, and it starts to do aging again. Okay, so you can see that this has been updated from 10.0.12.2. I'm going to do an authentication between R1 and R2. So we are going to do the RIP authentication. All right, so I'm going to do a RIP authentication on R1, R2, and see what will happen on our Wireshark over here. So let's go back into R1 in the serial 100. I'm going to do a RIP authentication mode. I'm going to use an MD5, and I'm going to use the usual format. I'm going to use a plain, as in the plain format when we do a display current. I'm going to do an Huawei. Okay, so remember that I have this authentication, and you notice that I have a 1.1 over here. Now, because the authentication between R1 and R2 are different, so R2 will not receive the network number 1 after a while. So if I do a display RIP 1 route, as you can see that the second now is already aging up to 34 seconds, and it go into 40 seconds. And you still remember that our update timer should not more than 30 seconds. Now anything between 30 seconds and 180 seconds, it will actually go to the aging. Okay, as you can see that now I have up to 54. But this route is still valid. Okay, as you can see that I'm still able to ping. And it will become invalid when it hit up to 180 seconds and above. So if I just do one more time on this, you can see that it's still in aging mode. All right, 68 seconds. So I'm going to pause this video, and I will come back to you when it's closer to 180 seconds. Okay, so the route already aged up to 132 seconds. And one more thing that I want to show you here is when R1 have this authentication between R1 and R2, as you can see that I'm still able to ping. All right, I'm still able to ping to the network. And you will notice that between R2 and R3, you will expect that the R2 doesn't send this information to R3, which is not. You'll notice that the most recent update was 2 seconds ago. So in over here, the update that is not received by R2 between R1 and R2 will still send this information to R3. So now let's see our aging here, and almost come to 180 seconds, and now it go up to 180 seconds. You notice that it go into RG. So now if I'm going to do a ping to 1.1, you notice that it's unreachable. All right, because it's in garbage collection. And when I go to R3, and you notice that now it's actually going to the garbage collection. So when R2 doesn't receive this information and it's actually going to the garbage collection, then R2 in return is going to send this information to R3. So after another 120 seconds, this route will be removed. So for me to reinstate this route, I need to use the similar authentication. But before I go to the authentication, let's have a look onto our Wireshark. So if you look into the Wireshark, you notice that there's such information saying that is a malformed packet. Now, if you look into here, there's a difference on the version 2. In version 2, you notice that right now I have a response. I have here the RIP. You notice that there's an authentication key. As compared with 12.2, I do not have authentication. You notice that I have an address family. All right, this is what I mentioned early on in my slide. This address family is being used as an authentication. Okay, and right now they weren't able to authenticate not able to authenticate each other. So for me to make sure that they can authenticate with each other, I go to the R2 serial 100/00 RIP authentication MD5 usual. I'm going to use a plain Huawei. Sorry, it's Huawei. Okay. So once you have configured properly, when I do a display RIP1 route, so we just wait for the route to be propagated again, you're able to see the 1.1. There you go. All right. So that's conclude our lab on the authentication as well as the trigger update.
Thanks for watching. Please do not forget to subscribe to our channel.